Bismillahirrahmanirrahim. Assalamu alaikum student. I am physics teacher from IYS school. Now follow the instruction. Don't raise hand during lecture. Ask question at the end of the lecture in chat box only. Use hand free if you are using mobile and headphone for computer use. Feed your ID and password properly with your name and class. Take care of time for attending the class. Home tasks should be done in your fair copy of the subject. If there is any disconnectivity during the lecture, try to join lecture again within 5 to 10 minutes. Student, today I'm just going to start the previous chapter of kinematics of linear motion. So yesterday we have done rest and motion, types of motion, scale and vector quantity, and today we are just going to start distance and displacement. Now, you know very well the term distance we have listened very carefully, but if anyone asks to definition of the distance, so what did you think about it? What do you know about the distance? So we can say it is defined as the property created by the space between two objects or points. Distance means we can say that it is defined as the property created by the space between two objects or points. It means that if we are taking a point A and another point B. So the distance between point A to B we can say, or the length between the point A to B, that is said to be the distance. Now we have learned in the scalar and vector quantity, scalar quantity are those which can be represented by the magnitude and the unit. So we can say the nature of the distance is scalar quantity. Here we don't have to be specified and describe about the distance. So or about the direction. So we can say distance is a scalar quantity. Now the symbol which we are representing a distance, that is said to be the S, and the formula for finding the distance we are using, distance is equal to speed multiplied by time, or according to the symbol we can written as S is equal to speed mean V multiplied by time mean T. So the formula for the distance will be S is equal to V multiplied by T. And the unit of the distance is meter, because distance can be expressed by the length. And we have learned in the chapter number 2 that the unit of the length is said to be the meter. Now, another thing is that another thing for the distance, if we are going to represent the direction, so it will become the another physical quantity, that is said to be the displacement. Now displacement can be defined as the shortest distance covered by a body in a particular direction. Again I'm repeating this one. It is defined as the shortest distance covered by a body in a particular direction. So it is said to be the displacement. If we are saying that, Miss, I'm going to take water, it means that I'm going to take water means at the cooler point or drinking point. So that is showing the direction. So it means we are covering distance from the classroom up to the drinking point, or we can say drinking cooler. So that is showing the particular direction. Displacement is also represented by the capital S. But to mention it is a vector quantity, so we can say an arrow will be put on the S. So we can say the nature of the displacement is a vector quantity. The nature of the displacement is it is a vector quantity because with respect to their magnitude and the unit, here direction is required. So that's why we are saying it is a vector quantity. Now the next one is displacement. Formula of the displacement is equal to velocity multiplied by time. Displacement is equal to velocity multiplied by time. So displacement is represented by S arrow is equal to velocity is represented by V arrow multiplied by T. Mean time is represented by the small t. Now here, if you are going to compare the distance and displacement, then you can observe that here in the distance we are using V because that is the speed, while in the displacement we are also using the V, but when we are putting an arrow over the V, then it will turn into the velocity. Did you understand? Now we are going to the next point. Next point, difference between distance and displacement. Our next point, the next topic is difference between distance and displacement. Now, before going to differ it, first I'm just going to again explain distance with respect to the diagram or picture. So here distance we can say if we are covering distance from point A to C, so it is not in a particular, so that is said to be the distance, and that is the space between the 2 points, point A and C. Now after that we are going from point P to the point D, so also we have it having an space, and this space is said to be the distance. And another we are covering a distance from point D to B, so it is also a space between D and B, so that is showing the distance because here there is no particular direction. Now on other way for the displacement we can say the definition of the displacement is the shortest distance covered by a body in a particular direction. So here look at the pictorial. A to P is said to be the shortest distance. Point A to B is said to be the shortest distance, and it having the particular direction. So that's why it is said to be the displacement. For finding the difference or to write the difference between the two object, so first of all we just have to write the definition. So first we are writing the definition of the displacement: the shortest distance covered by a body in a particular direction, while distance can be defined as the property created by the space between two objects or points. Now the second point of the displacement is this: it is a vector quantity, while distance is a scalar quantity. Now the third point of the displacement is it is represented by S and arrow, while distance is represented by only capital S without arrowhead. Okay. Now the next one is the next physical quantity after the distance and the displacement come here, that is said to be the speed. Now speed we can say it is the another physical quantity which most of the time we are listening in our daily life. Speed, we can say that the distance covered by a body by a in unit time, the distance covered by a body in unit time is known as speed. Mean, if we are covering some distance, then we will consume some time. So it means that that is the ratio between the distance and time. So we can say it will become the another physical quantity that is said to be the speed. Now, the next one is formula. What will be the formula? Formula of the speed will be speed is equal to distance upon time. Speed is represented by v, while distance is represented by s, and the time is represented by t. After that, we are coming to describe their unit. So, if we focus on the formula, then we can say we having the distance, and the unit of the distance is meter. And the second is time. The unit of the time is second. So in other words, we can say that the unit of the distance is meter per second. The unit of the speed is meter per second. Now, the nature of the speed, we can say it is the scalar quantity, because for the speed, no direction is required. So that's why it is said to be the scalar quantity. Now, the second one, we can say that average speed. In the mathematics, we have learned that average means the total distance or total quantity divided by number of quantity. So if we have to be focused that average means the total distance traveled during particular time, total distance traveled during particular time divided by that time interval, divided by that time interval. So it will become the average speed. So it will become the average speed, or we can say average speed is represented by capital V in the below AV. So it is representing the average speed. Again, I'm repeating the definition of the average speed. Average speed can be defined as the total distance traveled during particular time divided by that time interval. Mean how much distance we have to be covered, as well as how much time we are taking to cover the distance. So that becomes the average speed. Now, the next we can say we having two type of the speed. First, we can say it is a uniform speed, and the second one we can say that is a variable speed. Uniform speed, we can say equal distance covered by a body in equal interval of time, then it is said to be the uniform speed. Let's suppose that we can say equal distance. Let's suppose if we are covering the 2 meter difference during 2 seconds, while another we have to cover 2 meter distance during the 2 seconds, as well as we have covered the 2 meter distance in 2 seconds. So you are observing that here distance at the time is equal in all of the situations. So we can say that is said to be the uniform speed. But the another one is said to be the variable speed, and variable speed can be said at unequal distance covered by a body in unequal interval of time. So that is said to be the variable speed. Unequal distance covered by a body in unequal interval of time, then it is said to be the variable speed. So we can say that, let's suppose I'm covering a distance 2 meter in 2 seconds, while the another distance we are covering 4 meter in 3 seconds, while the another one is covering a distance from 7 meter in 1.5 seconds. So here you are looking that all of the distance are different as well as all of the time is different. So that's why that is said to be the variable speed. After that, we can say the another physical quantity we are getting, that is velocity. Velocity, we can say another velocity is the another physical quantity. But the difference is that in the speed and the velocity is that in the speed no need of the direction, while the velocity need direction. So we can define as rate of change of displacement with respect to time is known as velocity. Here the most important thing, here we are using displacement. Here we are using the term displacement, and displacement we can say it is a vector quantity. We are covering this distance in a particular direction in unit time, so that's why it becomes the velocity. Again, I'm repeating the definition. The rate of change of displacement with respect to time is known as velocity. Again repeating, the rate of change of displacement with respect to time is known as velocity. And the formula of the velocity will become velocity is equal to displacement upon time. And symbolically, we can represent it velocity v over arrowhead, while distance over arrowhead. So distance will come into the displacement while divided by t. So v is equal to d over t. Now its unit will become meter per second, as similar to the speed. For the unit of the velocity is as similar to the speed. Now, the nature of velocity, we can say it is a vector quantity. The nature of the velocity, we can say it is vector quantity. After that, we have learned in the distance uniform speed. Previously, we have learned uniform speed. So, here velocity also having the uniform velocity. So, we can say that when speed and direction of motion of a body do not change, the velocity is said to be uniform. Mean when speed and direction of motion of a body do not change, the velocity is said to be uniform. It means that we can say equal distance displacement covered in equal interval of time, then we can say that is the uniform velocity. With equal displacement covered by a body in equal interval of time, then we can say it is said to be the velocity. Now, let's suppose we are covering displacement 4 meter in 2 seconds and their direction is from point A to B. Why? The another one is another displacement we are covering 4 meter in 2 seconds and their direction is from B to C. Another displacement we are covering from C to D and distance is 4 meter in 2 seconds, and another one is 4 meter in 2 seconds from direction B to E. So it means that here all of the displacement are equal in equal interval of time while all of the direction are similar. Mean in other words we can say it is just going towards east. A to B towards east, B to C towards east, C to D towards east, D to E towards east. So it means that is said to be the uniform velocity. After that, the another physical quantity comes that is said to be the variable velocity. Variable velocity, we can say that a body is set to move with variable velocity if its rate of change of distance moved with time in specified direction is not constant, or in other words we can say unequal displacement covered by a body in unequal time or in unequal direction. So it means that that is said to be the variable velocity. The first thing is that here the distance is 4 meter. Here the displacement is 6 meter. Here displacement is 5 meter. Here the displacement is 3 meter. While all of the time are similar. All of the time are similar. So we can say unequal displacement while the direction is the similar when towards east and towards east. So here we can say that their distance are different. So in this regard we can say it is said to be the variable velocity. Somehow we can say if the distance and the time are similar but their direction is different. Let's suppose we can say a fan is moving. So the motion of the fan, we can say here, their speed and the time is equal, but at every point their direction is going to be changed. So that's why we can say it is the variable velocity. As well as if the direction is similar, let's suppose, and displacement is similar, but that is not getting the equal interval of time. Let's suppose this is 2 seconds, this is 3 seconds, this is 5 seconds, this is 6 seconds. So there are the change in the distance and there is a change in the time, then we can say that is a variable velocity. I discuss about the another topic, that is the acceleration and their equation. Now, first of all, the another we can say the another physical quantity is said to be the acceleration, and acceleration can be defined as the rate of change of velocity of a body is called its acceleration. The rate of change of velocity of a body is called its acceleration. Mean we can say that if we are going to start an object to move, so there are two velocities. The first one we can say is the initial, and the second one we can say that is the final. And from where the body is going to be start, then it is said to be the initial velocity. And when it is going to attempt or acquire the some speed, that will become the final velocity. Initial velocity is going to be represented by the vi, while the final velocity is going to represent by vf. Now here for the acceleration is represented by the small a, and their formula will become acceleration is equal to change in velocity divided by time. Acceleration is represented by change in velocity divided by time. Now, according to their symbol, acceleration is represented by the small a, while change in velocity is represented by the delta v, and the total time is represented by the delta v. Again repeating, the formula for the acceleration is change in velocity divided by time. A is equal to delta v upon time. Now, the unit of the acceleration will become meter per second square, or it can be represented m s raised to the power minus 2, and their nature will become, it is a vector quantity. Acceleration is a vector quantity. Acceleration is a vector quantity. Understand? Now, the next, we are just going to understand how we are getting. We are just first of all understand about the statement. Let's suppose consider body whose velocity changes from vi to vf in a short interval of time delta t. As velocity of the body is changing, hence an acceleration a is produced in it. Let's suppose it is a body. So this body is just going to change their position from this point to that point. So at this position, it is in the initial velocity. Let's see, and this is said to be the final velocity. Now that's why it is just going to change their position. Or the next way, we can say change in velocity of the body in time delta t is equal to vf minus vi, and that is represented by the delta v. Now the next way, therefore, we can say that change in velocity in unit time is equal to delta v over delta t. Now, on the next way, we can say that the rate of change of velocity can be represented by the delta v over delta t. Now, on the next way, we can say that since the rate of change of velocity is called acceleration, which is denoted by a. Now, the next one we can say, so a is equal to delta v over delta t. So, which we have learned in the previous one according to the definition of the acceleration. So, from this situation, acceleration is equal to delta v over delta t will come over it. Okay, student. Now, today we are just going to check the home task. Define the following term: rest, motion, distance, displacement, acceleration. Write down the three difference between scalar and vector quantity. Now, okay, student. Thank you so much. I hope so you will understand.